Good morning. Hope you're enjoying your 2-hour delay Wednesday. So I'm going to try to keep the video short so you can get to your assignment. All right, today we're going to talk about the slope formula, which is a way of finding slope without a picture. So what we need is the coordinates of two of the points on the line. And we call point 1 x sub 1, comma, y sub 1. So this right here, x1, comma, y1, where those ones don't mean anything. They're not actually part of the problem. All they're doing is kind of like giving you basically a reference to the fact that it's point number 1. And then point number 2 is called x2, comma, y2. And you can see those little 2's. They're subscripts. They're written down below, kind of like an exponent, but on the bottom. And again, they don't mean anything to do with any of the work. It's just telling you, hey, these ones right here, they come from the second point, not the first point, because that's important. We have to keep that organized, because down below in that green box is our slope formula. We have to take the y2 number, which again is the number in this location right here, and we have to minus the y1 number, which is the number that's in this location. Follow it up in the denominator with x2, that's the number in this spot, minus the x1 number, the number from this spot. So again, the location and the way that we name the points is extremely important. Without it, you're going to get every single answer wrong. So let's try a couple problems. All right, so here we're going to find the slope between the points 2, 7 and 4, 1. Now, the other day we talked about how we could graph them over at 2 and up at 1, 2, 3, 4, 5, 6, 7. We could put a dot in at 2, 7 and then go put a dot in at 4, 1, and we can see it's negative, and then we could count our rise and run and see what the answer was. You could definitely do it that way, but that's time consuming. You'd have to draw the graph and make sure you drew it nice enough you could count clearly, because on my graph, I don't know if I could count very easily on that. It's kind of sloppy. So instead, we use the slope formula. So here is my first point. We'll call this point 1. That means this is the x1 coordinate and this is the y1 coordinate. And then this over here is point 2, meaning that this is the x2 and this is the y2. Just, again, place values. Just telling you where things should come from. Right, now let's look at the formula. Formula says y2 minus y1 and then x2 minus x1. All right, so the y2 number, that's where we're going to start. And then there's a minus sign in each the top and the bottom. So let's go find the y2 number. Oh, the y2 comes from point 2. That's what the little 2 stands for. Point 2, y coordinate, this number right here, 1. And then there's a minus sign that's always there. And then the y1 number. Well, the y number is the y coordinate from point 1, the 7. Now in the denominator, x2. That's the x coordinate from point number 2. That's this one over here, the 4. The minus sign is always there. Now we want the x1 number, the x coordinate from point number 1, the 2. Now we subtract. 1 minus 7 in the numerator, negative 6. If you're bad with those types of things, use a calculator. And then 4 minus 2 in the denominator, which makes positive 2. And just like yesterday when counting out slope, we always have to reduce our fractions. Again, also use a calculator, just divide those out, and you get the whole number, negative 3. Let's try another one. Right, once again, you have an option. You could make a graph, and then you could go over left 2 and down 4 and put in a dot, and then you could go over 6 and down 2 and put in a dot, and then you could draw a line and you could count your slope, rise and run. But again, that's hard to do just because it takes too much time. Instead, we're going to use this slope formula. Now remember, this is point 1 on the left, the negative 2, negative 4, so that's my x1, y1, and the reason it's called that is because this is from point number 1. And then the other one's called x2 and y2 because they come from point number 2. That's what those 1's and 2's mean in the formula. So in the formula, in the numerator, I'm going to subtract my y numbers. In the denominator, I'm going to subtract the x numbers, and yes, the order you'd put them in absolutely matters. If you put them in the wrong order, you'll get the wrong answer. So first off, the y2 number, again, that's the y coordinate from the second point. That's this number right there, negative 2. Then the y1 number, that's again the y coordinate from the first point. And it's right there, -4. And something happens in that numerator. There was a minus sign, the one in red, that was already there from the formula. It was already there. Now we got another minus sign with the -4. And hopefully you remember what to do when two minus signs get back to back. Two minus signs back to back will change to a plus sign. So instead of minusing -4, you can just change that to +4. Definitely a place to make a small error. Now the denominator, x2, that's my x coordinate from point number 2. That's over here, that's the 6. And then minus, again, that minus sign right there is already in there from the formula. And then my x1 number, what x1 number is over here, and it was -2. And it happened again. I have two minus signs right next to each other that will act like a plus. Now, numerator, -2 plus 4 is 2. Denominator, 6 plus 2 is 8. And I can divide both of those numbers by 2. So if I divide both numbers by 2, I get 1/4. There's my reduced slope. No decimals here. Fractions. No decimals. Fractions. It's not much fraction work other than at the end, the reducing part. The rest of it's just adding and subtracting with negatives. All right, now, might be asking yourself, well, why can't I just graph these and do rise over run every time? And here's why. What if you had this problem with these numbers? I do not want to draw a graph that counts out to 114 or 23 even. So drawing a graph would be almost impossible. So instead, what you'd do is you'd take the y2 number and minus the y1 number. Then denominator, the x2 number minus the x1 number. And then you could just do it this way. You'd end up with -151, and then those will act like a plus, and you'll end up with an 87, and there'd be your answer. It's ugly, but man, that's sure way faster than drawing a graph big enough to count all of these things, and then counting the spaces between all of those dots. So that would be really annoying. So again, that's the purpose of this formula, is for when the picture would just be too annoying to actually have to draw. All right, good luck on your work today. There's only like 5 or 6 of these, so it should go pretty quick.